Hello, we're going to be talking about function basics. We're going to walk through some function declarations, expressions, arrow functions, and even talk about an elusive function for new developers called the IIFE, immediately invoked function expression. So first, we've got to figure out what is a function. Well, simply put, a function allows us to execute some code and is protected by a block of scope. So in our case, these curly braces are protecting the return value in here. So functions allow us to hold something in memory until we need to use it. They're really useful, and in JavaScript, they're even more powerful than in some languages. We'll get into that more later, but for now, let's focus on the syntax of what a function looks like. Specifically, I want to say this is called a function declaration. A function declaration has some unique abilities about it. Number one, it is hoisted by the compiler so you can invoke before you define. That means I can define my function down here, and then I could actually invoke it or call the function. So I'm going to go ahead and grab this console that is commented out here, uncomment it, and let's see if this works. I'm going to hit run, and you can see it did indeed add 2 numbers. So that's pretty crazy. In some languages, this would not work. And in some ways that we use functions, it won't work. So a function declaration, when it is defined, actually is hoisted by the 2-pass compiler in JavaScript, which allows us to do this kind of funny thing here. Now, this could be seen as a feature or a bug, depending on who you work with. But as long as you know it's there, you can have power. So in this case, oftentimes, just to keep things easy for the next developer, you will find this pattern to be more common. Let's see if this works though. Clear and run. You can see it does indeed work. So let's talk about what is actually working here. So I'm going to get out my annotation tool here. I want to talk about what's going on. So number one, to even see this in our console, we're using a statement called console.log. Console.log is part of the document object model, which is beyond the scope of what we're talking about today. But it allows us to see content inside of here, the console. So we use console.log to see the values that are procured by our function. That being said, how did we get those values? Well, inside of here, we have what's called an invocation. Invocation is a super fancy word for we're calling the function that we wrote. So in this case, I've got add. There's add right there. And then I'm passing in 2 arguments. Arguments are the values that are being passed in to the function. So in this case, I've got a 2 and a 2. So what happens is, when I invoke this function add, I'm actually substituting 2 here and 2 here into the parameters. Now I want to be super clear. It does not matter what those parameters are named. So if I came in here and I change them, as long as I'm consistent, it doesn't matter. So I could say whatever, and as long as the matching order matches the argument order, we're good to go. So as long as this is 2 and this is 2 in that order, it does not matter what that's named. So let's see if that still works. You can see it does. So parameter names don't matter more than the order. That being said, they do matter when you're working on a team and you want people to understand your code. So there's a human readability problem if you're at least not telling the next developer what you want to do. I have seen a lot of developers that will do something like this, A and B, because to them it just makes sense. They don't want to bother with trying to set parameter names. It really depends on where you work and what kind of standards you have. But in our case, we're going to try to be descriptive of the next developer and say, hey, I've got a number 1 and a number 2 that need to be passed in. It's not the exact num1 and 2, it's the order in which the arguments receive. So if I were to draw this out, this 2 gets assigned to that parameter, this 2 gets assigned to that parameter. If I were to change the argument values like this, from 5 to 8, just so we're not confused by the number 2 at all, you can see here that the same rules apply. So if I hit save and run, let's see what happens now. We get 5 plus 8. So hopefully you're seeing that, light bulbs go off and you're like, oh, okay. The arguments are the values that we pass in, the parameters are placeholders, and the order in which they are, the order in which those parameters sit inside the function matter more than their names. Okay, so now that we have a better idea of the syntax or the way in which we write functions, we then have this interesting return keyword. So what return is doing is the terminal statement, which that means it is the last statement that will be understood by the function. Anything after this statement will be ignored. For example, if I tried to say console.log, testing, let's see if that runs. Save, clear, and run. You can see testing did not fire. But if I put that log before the return statement, let's see what happens. There it is. So this return statement is actually a signal to the developer and the compiler that this function is done. So please be careful to never put anything after the return statement if you want it to execute. All right. So in this case, we are returning the result of the two values being added together in this case. And then we're console logging them out. Pretty cool. So this is a basic function declaration. You'll see this quite a bit in JavaScript. But let's move into something a little bit more interesting and syntactically different. So if we come down here, we have anonymous functions. I'm going to go ahead and comment out the console log and focus on anonymous functions here. Anonymous functions are not hoisted. So what that means is I cannot invoke the function before it has been defined. So if I take this console log, well, first off, let's just see how this thing even works. Save and run, see if this even runs. It does, we get 16, cool. So what I'm going to do now is I'm going to take this same console log, I'm going to put it before. I'll comment this out while we try. Let's see if this runs. Run, not working. If we were to look under the hood here, you would see in our console, multiply is not defined. It doesn't even know it exists. This is proof positive that function expressions, that's what this is called, are not hoisted by the compiler. Therefore, if we have a function expression, we have to let it be declared first, and then we can invoke it. That is the proper way. So that's a big difference between, of course, our function definitions up here that or declarations that we were talking about. Okay, so that being said, by the way, these are often called function declarations or definitions, sometimes used synonymously. It can be confusing for a new developer, and I get it. But one telltale sign of an expression is an assignment operator. So inside of here, notice there's no assignment operator. We've got the function keyword and a name. But if we come down to an expression, we have a let. In this case, we're using a variable to hold this. We have a value here, a name value, and then we have an assignment operator. And then something interesting happens. We have a function with no name. Notice there is no name. I could put a name on this, but usually you don't see that when we're using function expressions. So in this case, this function has no name and actually fires when it's invoked by the value of the variable. That's pretty crazy. We're using a function on the right-hand side of an assignment operator. This is definitely unique to JavaScript. And so while other languages can have function expressions, JavaScript operates really well on these premise. So let's see how they're very similar to the other thing that we talked about. So we have multiply. Well, look how we invoke it. Multiply, open and close parentheses, passing in our two arguments. Looks the same as our add. So notice the invocations are identical. That's great. At least we have some consistency there. But where things get interesting is where we have this anonymous function, num1, num2. But then once we get inside our curly braces again, we're back to normal. We've got our return statement just like we've seen before, and things go well. So why do we even have these? Well, oftentimes function expressions are used when we don't want to invoke something every time. We want to control when it's invoked. So often function expressions are used as for more control for developers. Also, function expressions are usually anonymous. So syntactically, a lot of people prefer them when using them in an event handler or objects. They're passing in different values and they don't want to have to write names out. So function expressions are really powerful. Oftentimes you will see them being anonymous, meaning they don't have an extra name here. Now you might be saying, wait a second, I see a name over here, but understand that's not the function's name. That's the name of the variable. So be careful. So interestingly enough, function expressions have brought on a whole new syntax as we talk about ES next, basically ES6 and above, called arrow functions. So arrow functions are a derivative of function expressions. So now that we have a base understanding, these rules all apply, meaning they're not hoisted. But then we gain a whole bunch of new rules. So arrow functions have a shorter syntax in general. They do not bind the this keyword. It's out of scope for what we're talking about right now, but I do want to mention that that's one of the main features and one of the only reasons why you'd ever use an arrow function, besides the shorter syntax that a lot of people prefer. There is a do not use list, though, that's much longer than other functions. And that is because of the binding of the this keyword, the non-binding, I should say, makes it so this is not a good candidate for these. These concepts we will continue to cover in the future. But I do want to at least let you know the arrow functions in some cases are not the best thing to use. So when should we use them? Well, oftentimes we see them in array methods, and developers love to use them in place of any time that they see a function expression, because they are function expressions with different syntax. So if we were to compare one-to-one, if I were to bring this down here and show you what the conversion looks like, it's pretty simple to see. You just simply remove the function keyword and introduce a new symbol that looks like an arrow. So the assignment operator with this open alligator face, greater than symbol. So in this case, this looks like an arrow. So they call them arrow functions. That is it. So let me do it again. Whoops. So I have my function. I delete the function keyword and I introduce an arrow. This is the most simplistic conversion into using an arrow function. This is kind of where I want to stop and say, for what you're doing right now, this is where we just need to go, okay, cool. I've seen an arrow function. I know what it looks like. I know it's from a function expression. Those are the kind of things I want you to have right now. So at this point, I'm feeling good. Everything I talk about now is just extra. So arrow functions, because of their short syntax, they have a lot of different abilities that normal function expressions don't have syntactically. Okay, that's kind of a mouthful. So what does that mean? Well, given a certain subset of rules, we can actually get rid of even more syntax. For example, if I'm only returning one value inside of an arrow function, I actually don't even need the curly braces anymore or the return statement. It's implied, meaning it's automatic. I can even get rid of the curly brace there. That's still valid code right there. First off, let's see if this thing even works. So I'm going to bring in this console log. Notice that it's below the definition because it's still an expression. So I'm going to say run. And there it is. 10 minus 4 is indeed 6. Okay, what about our fancy arrow function here? Let's see if that still works. Save, run. It still works. So you can see here that syntactically, we cut out a lot of fluff. We don't need the curlies. We don't need the return because they're implied. Because when we use this arrow, the compiler knows we're doing something special and has a different set of rules. This is just one of many examples. I'm not going to go over every example because I really just want you to focus on the basic arrow conversion that we did here and kind of like scratch this from your mind for a second and just focus on this. It's going to do you huge favors to just get into the habit of trying to convert these from normal function expressions to arrows and back again until you feel really comfortable. All right, there is something even more advanced than an arrow function, and it's called an immediately invoked function expression. So in this case, I'm saying this is totally extra for now, but it is fun to talk about. So this does not require an invocation when referenced. It is also a function expression. So you can see here that this syntax looks a little crazier than what we've been used to. We have talk, and then we have this function, but notice what's happening here. Notice how we have this open and closed parentheses right there on the outside. We then have a function which is then invoking. And inside of these curly braces, we have a return statement. But then there's another set of parentheses at the end here invoking the function without having to go into it when we write the definition. So I want you to notice right here, when I say console.log and I say talk, notice that I'm not invoking talk. I'm just referencing it. This is one of the interesting behaviors of an IIFE, or immediately invoked function expression. So for example, if this was not an IIFE, I would have to invoke my function like that. But because it's immediately invoked already here, I don't have to do that when I reference it. Pretty wild. So let's see what that looks like. Clear and run. And you can see that it did return the string, I was invoked immediately. Wow, that's pretty cool. Let's not get caught up in IIFEs right now, but I do want to show them to you, get you excited about what future holds in JavaScript. And hopefully you're scratching some itch and you're going, oh, this is cool. But come back to the top, look at the function declarations that we've been talking about, the original definition, the non-hoisted function definitions here. See the difference, study the difference between these, a function expression, and then ultimately what an arrow function can do for us. Because they are prevalent. You can't get away from them in programming in JavaScript. They're all over every library that you're going to be using in the future. So it'd be good to embrace them now and not later. Okay, thank you.